Hello friends, this video on aldehyde ketones carboxylic acid part 17 is brought to you by examfear.com. No more fear from exam. Now we'll discuss oxidation tests to differentiate between aldehydes and ketones. We have already told that aldehydes differ from ketones in their oxidation reaction. In fact, aldehydes are more reactive, right? We have told that aldehydes are more reactive than ketones as far as oxidation is concerned, because aldehydes are easily oxidized by common oxidizing agents. For example, HNO3, KMNO4, K2Cr2O7. Even the mild oxidizing agent, for example, tollen agent, fehling agent, these agents also oxidize aldehydes to carboxylic acids. So I have aldehydes. It can easily be oxidized to carboxylic acid even by mild oxidizing agent, right? And mild oxidizing agents are like tollen reagent, fehling reagent, and the strong oxidizing agent will obviously oxidize, but even mild oxidizing agents will oxidize them. But the ketones, they are oxidized only under vigorous condition. If you are using mild oxidizing agent, or you have to use strong oxidizing agent, high temperature, then only the ketones gets oxidized, because in this case you have to break these bonds, right? And you get RCOH and RCS2OH, something like that. But it needs vigorous condition to oxidize. But aldehydes oxidize pretty easily. Thus, there are two tests, actually, tolerance test and fehling test, to differentiate between aldehydes and ketones. Let's understand tolerance test. So typical reaction for this tolerance test is also called silver mirror test, by the way, is you have RCOH, that is my aldehyde, and you have AgNH3 plus, and it happens in the basic medium, so OH minus, it gives RCOO minus. You see, this is my carboxylic acid plus silver plus water and ammonia. This is my, if you see, this is my silver, so I get the silver lining on the tube, test tube. This is also called silver mirror test, and happens in alkaline medium. So if we have to differentiate between aldehyde and ketone, very simple, just go for tolerant test. So if you get the silver lining on the test tube, it is aldehyde. If you don't get, if there is no reaction, it is ketone. So now we'll discuss about Fehling's test. This test is also used to differentiate aldehyde and ketone. So Fehling solution, first before we discuss Fehling test, this is my Fehling solution actually. One on the right hand side, this is my Fehling solution. The whole thing is Fehling solution, and it has to be freshly prepared, right? So it contains this complex copper tartrate. It's complex copper tartrate. You see, it's copper here. It's complex copper tartrate, and it is prepared by mixing two solutions, Fehling A and Fehling B. Fehling A is nothing but my copper sulfate. It is nothing but copper sulfate solution, which is blue in color, and Fehling B is nothing but my sodium hydroxide and potassium sodium tartrate, also called Rochelle salt. This is my potassium sodium tartrate, so it is called potassium sodium tartrate. So you have to mix this in the same ratio, 1:1 ratio, and you get this complex solution, complex copper tartrate. This is called Fehling solution, right? And the beauty of this solution is it will again oxidize, its oxidizing agent. It will oxidize aldehydes to carboxylic acid. Correct. So this solution as such is almost blue in color. So if you talk about the whole solution, it's almost blue in color. But when it oxidizes to carboxylic acid, it gives red-brown PPT. It gives actually Cu2O, that is nothing but red-brown precipitate. So if we get red-brown color by fehling solution, that means it is an aldehyde. And please note, aromatic aldehyde don't respond to this test. So if you have aromatic aldehyde, you see it will react to Tollen's test, but it will not react to fehling's test. So till now what we have studied? We have studied Tollen test and we have studied fehling test. You remember this. So Tollen test is all aldehyde, no ketones, and fehling test is non-aromatic aldehyde. Or you can say aliphatic RDX. So these are the two tests we have studied. So with this test, we will solve some questions where we will be asked to find out compound which reacts with test A, test B, stuff like that. Just remember this: Tollen test, all aldehyde; fehling test, non-aromatic aldehydes. The next is oxidation of ketone haloform test. So this is only for methyl ketone. Please note, this is only for methyl ketone. Methyl ketone actually. So we have a methyl ketone, CS3 here. This is the methyl ketone, right? When you treat with halogen, any halogen, and sodium hydroxide solution, it will oxidize this ketone to carboxylic acids, which will have one carbon less because the CS3 will go off, and this becomes CHX3. And X can be anything: chlorine, fluorine, chlorine, bromine, or iodine. Yeah. X can be chlorine, bromine, or iodine. This is used to detect methyl ketone group. Right? For example, I'll take you have this CH3, CH double bond. Let's suppose this test. This is my methyl ketone because ketone means a methyl group. You add some chlorine, NOH, you add 3 chlorine. What you get is nothing else is broken except this ONA, and it becomes CHCl3. Correct. This is only used for methyl ketones. Thank you. Visit our website examfear.com to watch more and more quality educational videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.